So I'm going to preface this talk by saying that I am a Unix administrator and I'm not a public speaker. It's my first talk. I was told to picture everyone in their underwear, and you all look fantastic. So let's go ahead and get started. So I'm a senior Unix administrator for a hosting company here in Colorado. I've been a user of Puppet open source since 2008. I've actually never used Puppet Enterprise before. I am the author of the external node classifier Automaton. I wrote that out of necessity because, again, I don't use Puppet Enterprise, so I had to forge something for myself and my coworkers. And I'm also a recent maintainer of public modules. And I wanted to state that because I've been a lurker in the public community for quite a while. I haven't contributed that much, but it's one of the reasons for my talk here today. So I encourage you to either become maintainers of modules that you use, or simply just start contributing back. So welcome to the talk. This is geared more towards the beginner Puppet user, though you should have a slight understanding of the Puppet DSL. I'll be showing you quite a bit of code. When you have your modules, I'm trying to show you how to make them a little more flexible, a little more interchangeable, and how to standardize. Let's get started. So what is a module? The dictionary defines it as a standardized, often interchangeable component of a system or construction that is designed for easy assembly or flexible use. Those three highlighted items are things that I like to keep in mind whenever I approach a new module. I like to keep them modular. So how do you standardize? Who's standard? My personal modules and my module skeletons are based off of the Standard Mod naming convention. Standard Mod is a community naming convention that is being pushed by the people at Lab 42. And how can we make our, I'll talk a little bit more about Standard Mod later, just so you're familiar with it, but you'll be seeing parameters that are named from Standard Mod. So how do we make our modules interchangeable and why? Keeping your modules interchangeable can be extremely difficult, especially with public modules that you pull from the Forge. A lot of times you'll have names and parameters that are just haphazardly named by the module author. So it makes it a little bit difficult, and the learning curve for those modules increases quite a bit. Standardization does help with this. And lastly, what makes a module flexible? What does it buy you? A flexible module is a module with options. It provides the module consumers choices and how that they use the module and drive the behavior of the resources in that module. To understand how best to implement flexibility, it's my opinion that you need to have a slight understanding of the Trifecta Pattern. It's a fantastic pattern, but I find it's not always implemented in the best way. So let's go ahead and take a look at that. And if you've been using Puppet for any length of time, you've probably heard of and are using the Trifecta Pattern. If you don't know, however, it is about managing a package, managing a configuration file, or managing a service or daemon. And if you think about that for a second, you can essentially manage an entire node with just packages, files, and services. This is what we do all day. So can you develop a module using this pattern that is still flexible and interchangeable and standardized? I'd like to think so. So you might recognize this example if you've gone through the Puppet tutorial series for this is the NTP module on there. And this is a good example of the Trifecta pattern at work. It's installing our package, NTP, and making sure it's always installed. There we go. It's also laying down our Etsy ntp.conf, and it's sourcing our flat file version. As Spencer alluded to, this is coming from the file server on Puppet. And it's also taking our NTP service and ensuring that it's always running. It's also subscribing to the NTP file. Subscribe is a meta parameter. And what that does is basically, anytime this file is changed, it's going to restart the service. We also have a nice benefit of the operating systems. We have coverage for CentOS and Debian variants. So when you're setting up services like NTP here, or a web server, or a database, generally the Trifecta pattern works nicely. A lot of people say that there's a problem with the Trifecta. I've heard in IRC and read several blog posts that knock on it a little bit. I personally don't share that view. I think more of how it's implemented. Briefly, really quickly though, take a look at how easy to read everything is. You have all of your arrows lined up. We have single quotes. We don't have any double quotes where variable substitution is happening. So let's take a look at a not so good example. So like the previous example by Puppet Labs, you can see everything is hard-coded. We're listing everything here in our classes. Now, the difference here is all of our classes reside in a single init PP. I'm not sure why this is done, but it is how it is. We have separate classes for things that could be handled via parameters. This module definitely needs some love. Again, the small things that I noticed, or that I had you notice, see all the arrows are haphazardly thrown about, no real rhyme or reason. It makes it very difficult to read, very difficult to understand. This module definitely needs some love. And I'm not trying to pick on any module in particular, but before you start hammering away in Vim or gedit or whatever you use, stop and think about your module first. Think about what you're doing and how to approach it. So Puppet is more than just laying down packages, config files, and managing services. As Spencer said, it is about managing state. When you hard code items in your modules, you're only managing a single state. And why that will get you to a point in time that you need to be, you may not know who is intending to use your module, or if you're going to be publishing this module to the Forge for others to use. So in this case, if I have this module on the Forge, and I may be using AIX instead of CentOS or Red Hat, I have to modify the module now. I have to fork it, I have to make a new module, I may or may not share that. So taking this module as is, we're going to identify areas for improvement. So what we've done here, we've taken this case statement here that determines our operating system, and we moved this into another class called NTP params. And this is generally referred to as the params pattern. It's widely used. And params PP typically holds all of your same defaults and all of your customizable logic for your module. In this case, it's our operating systems. And you can see here the different variants, ntp.conf for enterprise Linux, for Debian, our default, different service names, and then we have our variable names. And these are used, so when Spencer was in the enterprise console and you saw those parameters that you were able to override, and they got automatically parsed in that list. This is what it's reading here. So those parameters, when they get override, they're set by the same defaults here in NTP params, but they're being overridden either with the Puppet console, another ENC, or site PP.
Question.
Yes.
Params file, what is that typically called? Is it params.pp?
Params.pp. Some people call it defaults, but the general pattern is params PP.
Thank you.
You'll find that is widely used if you download any module from the Forge. It's going to be just the same defaults that particular module author thought was the correct method to use. So really quick, these parameters, they're different than standard variables like here in the fact that now they are requesting that external data. They can be overridden. They're not hard set, and they can be reused. So what did this buy us doing this? Why did we do this extra work? Well, this bought us, first off, data separation. now I don't have my custom data littered throughout the module. It can be overridden, so it can complement the defaults here, or they can be completely changed. So take a look at how that would be called. If I had a custom configuration file, for instance, that may not be in may not be defined in params because I didn't think of it and I don't know all of your use cases, you can override this without changing the module. This is how it could look if you're calling this class within site PP. So you're calling your NTP module and you're giving it the parameter of comp file and you're giving it your new configuration file. So you can simply call this class because it was written with these class parameters. You could simply call this class now with that parameter and override that configuration file. And that is done without changing the module. So now I can pass in any configuration file I want, and I can continue to use and reuse this module on as many machines as I want. And if I have differences throughout my environments, then I can cope with that. And if you're just beginning writing your own modules, you may very well have something very similar to the foobar module here. You have your package, you have your file, and you have your service. We have a nice trifecta pattern. So we need to identify ways, instead of just rewriting your module, you already have one that works. So start identifying ways that you can make it reusable. A lot of times what happens, people start adding more and more logic into the module to try and cope with different behaviors, but it becomes quite unruly. So if you could just identify areas for improvement and parameterize them, you can allow people better options with how to use your module. So what we're going to do is identify these areas by resource. So how I like to do it is I like to start with particular resources I'm managing. So I have my package resource, my file resource, and my service resource. So I like to specify name. A lot of these in the title, that's what's called a name bar, and that'll typically take the place of name. But I prefer to explicitly list out name in my resources, and then just have arbitrary but meaningful titles. So when I go through a module, if I'm looking at it or if somebody else is looking at it, they can very easily see. I'm not listing package names, I'm not listing configuration file names. I'm simply saying, here's my comp file, here's my package, here's my service. But I'm having the real names in my name, my path, my name. So if we go by this resource by resource, everything in Linux and Unix being a file, you can get extremely thorough with the file resource. You want to be able to change the path. I mean, in almost 100% of cases, you're not going to be using a default configuration file. When we do a yum install or apt-get install, we typically go into the configuration file and change it. We're not going to have the default install and just keep going. We may need to have different path set, security settings enabled, change the amount of workers, what have you. So if we take these different parameters, or these different attributes rather, and parameterize them, we can allow people to change those resources and drive that behavior without modification. So we've identified our areas for improvement in our package, our file, and our service resources. We know we want to change these things, but we don't want to hard code them. So how do we do that? This is how it could look if you take those attributes and you parameterize them. Notice I have nothing hard-coded here. This is all being set from a default params pp file. These are sane, unopinionated defaults. So I can call that class with package name to change the package name. It's very common for people to build their own packages. So instead of NTP, you could have foo NTP. The package ensure. Sometimes I don't want it to always be installed everywhere. I want that package to be absent. So I would have to go into the package resource and actually put that to absent instead of present. Next, we come to our file resource. I also may not want the file to be there for some reason. I want to give the module consumer an option to remove it, a toggle switch, to install or not the configuration file. Configuration file path. In my job, we prefix all of our packages in opt. All of my paths are definitely changed. Yours may be, they may not be, but now you're able to. I'm not forcing you into a specific way of doing things that I thought was the best way. I'm giving you the option to use the way that you want to do it. Next, source. Well, again, you're going to want to put your own configuration files in there. I'm going to provide you with a default configuration, but odds are it's going to be very default. It's going to be something that just comes with the basic yum install or the apt-get install. But this allows you to pass another source to the file that you can go ahead and override with. So that way you're not using mine, but you're using yours. We get down to service. I also like to have a toggle for service being on or off. I may be doing maintenance on a machine, and I don't want Puppet coming behind me and turning back on that service. It's going to get in the way of my work. So a toggle to make sure it's running or stopped is very nice. Yes, you can turn off Puppet and manually stop the service, but I could even use something like PSSH or Fabric to roll through all of my machines and make sure that that service is off. But it's much easier to provide an override, and I can simply say, not running. Next, again, service name. Now, service names typically don't change, but I still find it useful to include it anyway. Some people may have differences. I don't get much use out of service name, to be honest, but I'm already parameterizing a lot. I might as well just throw that in. Next is enable. So with enable, I don't want it to come back on during boot. During my maintenance, and I'm rebooting, I want to be able to stop that service from starting the moment that the machine comes back online. This gives me the control for my timeline to get my work done. My job, we use change controls. I'm sure you guys have used them, and I have change windows that I have to abide by. So I want to make sure that when I'm doing maintenance, I'm going to go ahead and kill that for my window and then turn it back on when I'm done with my work. It's by a simple toggle. So you can see with very little work, we've simply taken the areas that we've identified, parameterized them, you still use the same layout, and added quite a bit of flexibility to this module. I can change any one of these resources. So by parameterizing all of those items that are in yellow here, that were identified for good candidates for parameters, now you have the ability to drive each one of these resources the way that you want. So can there be too many parameters? Absolutely there can be. This also ties in with interchangeable modules. This is a module that is clearly trying to do too much. While some parameters were added that were good and add honest flexibility to the module, there's some here that just serve only to lock you into that particular module. You won't be able to change this out with another module that's on the forge. If you do, you're undoubtedly going to run into resource conflicts. You're going to have to open up the module and remove the stuff out that you thought was a good idea, or just simply rewrite the module. So you may have, foobar may have an extension, and it may be applicable to that requires something like Apache or Nginx and Unicorn. But there's modules to handle that. There's modules to handle Nginx, there's modules to handle Unicorn, there's modules to handle Apache. Don't try and put them all into one module and make something monolithic. Remember what a module is. It's modular. It should be able to be unplugged and plugged in somewhere else. But if I'm unplugging 4 or 5 things and plugging it in elsewhere, that's not very modular. So here, when thinking about the modules and the parameters it should have, more is not better, as we just saw. But you do want to lay down a safe, unopinionated default installation of whatever it is you're managing. And then use your parameters to actually drive those resources and configure it the way that you want. And while this may look like a lot of parameters here, it's just giving you a common sense API to drive this module. You can see I'm not naming my module names anything ridiculous. Very clearly able to be written, or read, sorry. Package name, package ensure, package version. You can see that it's almost following the type of the resource that it's managing, followed by the attribute. So as we saw here, package ensure, package ensure, package name, package name. So that way, when you're looking at the type reference on Puppet Labs' website, and maybe you're looking at the documentation for this module, you can clearly correlate the two in your head. So some of the parameters here that were added that add some nice flexibility to the module that I like to add in is package version. Sometimes you just need a specific version of a package. So you're not always going to specify latest, but if you do, that's fine. This is there for a convenience factor for you to be able to, or your module consumers, to be able to install specific versions of packages. We also have now getting into configuration directories. Notice in the last, we were simply doing our package file service. This works fine, but adding a little bit more, you can get you a little bit further along. So configure path. You may have Nginx, not in Etsy Nginx, but in opt Nginx. So you want to be able to change that. Configure source. What this is used for, I'll show an example of this here. So when you want to sync an entire directory, so say I'm no longer a single file, but I want to sync an entire directory. I want to make sure that Etsy Nginx is synced with my version of Etsy Nginx, and not just a single file. You can use this style of logic to make that happen. So I am specifying my source, and I am specifying my source. I have a purge because sometimes you don't want to, you don't know what is in that configuration directory. It could very well be a bad configuration on hundreds of machines that you need to get rid of. So I like to provide a purge option as well to get rid of all of those files that are not in my source directory. And if you're purging, you might as well add recurse too, because you don't know the directory structure that is going to be on that, on there. There could be Etsy Nginx compd. There could be just a whole array of directories that are trailing down. So it's a good idea to provide your module consumers with the ability to recurse down into that directory as you're purging. Be very, very careful though. As you can imagine, it's an extremely destructive operation. So don't haphazardly use this and just start running it everywhere. This is how the override could look if you're using site PP, for instance, and you call it as a parameterized class. So I have my foobar class, my configure source that I have. So notice I'm not specifying a file at all, but simply my directory. Here we have the configure purge parameter set to true. So we can go ahead and purge everything that is not in my source. And then finally we have configure recurse. Obviously that's, you know what that does. It recurses down into the directory while purging. So you can see with some thought, you can add parameters into your module that help drive the behavior of resources without hard coding everything. That is the goal of a flexible and reusable module, is to provide your module consumers with options of how they can utilize your module with not modifying it. If they have to go into your module and to modify a configuration file path, it's frankly not flexible enough. It's not going to benefit them. It may save them work in the fact that they can run your module now on all their machines, but they still have to go in, figure out your module, read it, hope it's documented, and see how best to do that. So yes, you can add more parameters than what I've just shown you. Flexibility, zealot with meta parameters. You can get absolutely crazy with this. So meta parameters, if you don't know, are attributes that you can add to any resource. And you're probably already using them, like we saw subscribe, require, notify, no-op, and audit, though I believe audit is being deprecated, but don't quote me on that. So, adding in meta parameters, you can see the parameter list is growing, but to a point. We have the no-op parameter up here because you don't always want to run your entire catalog in no-op mode. You know that 50 of your modules work. Let them be applied. Your single module here can be run in no-op mode via a simple toggle. It'll show you exactly, kind of getting cut off down here, but it'll show you exactly what the module is doing as if you were running the entire catalog in no-op mode for this particular module. So you can have dry run capabilities for a single module versus your entire array of modules. You don't need to run no-op for all these modules that you know work already. Next, we have our meta parameters notify and require. Or, you can just specify these really, which is part of the reason why I do use arbitrary names here. So I can just specify service and package like this. So what these meta parameters are doing, if you don't know, this is requiring, before this happens, this is requiring that foobar package gets installed. Notice again the arbitrary title. So after that package gets installed, it's like, okay, I can go ahead and do my thing. Now it's going to use the meta parameter notify, and this is going to notify a resource that, hey, I'm finished. So this is going to notify service, foobar service, again, my arbitrary name. And a service is going to then run after file. You could do this with a subscribe as well and subscribe to the file. It's really a matter of preference. So here, as I provide them as parameters, even though they're probably not going to be changed, it may not buy you a whole lot, you can still go ahead and add it. You may find that because there are differences in package names, there are differences in service names, it's good to go ahead and define that so people can notify their own resources or what have you. They may even extend your class in a way that you didn't intend to. So that way you can provide them more options with how to drive those module behaviors. So we have all these parameters. We've spent a lot of time identifying our trifecta of what we can do to drive these module behaviors. So we have our common sense API now that everybody is, hopefully everybody will be using to use the module. But you need to validate. Spencer touched on this a little bit with validate array. You need to validate these parameters. You want to make sure that the data coming through to them is what you expect and will be used in the way that you intended. So, Puppet Labs has a module called Standardization. How many of you have heard of it and are using that? So, good, decent number. Standardlib is just a module. There's nothing special about it, but it does have a lot of functions that you can utilize. And I highly suggest that you do. Some of those functions that are used are validations. And since Standardlib 4.4, there's also a new function called private, which I'll also show here in a minute. So if you're not already using them, I highly suggest you go and download the Puppet Lab Standardlib module. You can do a Puppet module install and grab that. And here's some of the validation functions that it has. You can see that it has quite a bit. Validate absolute path, validate array, validate ages, validate rule, command, hash, IP addresses, regexes, string length, string. Here's some example usage. So it's very, very simple. And since we have our parameters, we just simply validate them right after You validate them right before you package resources. So I have my parameters, here's my entry point, and I'm going to validate them like this, very simply. So it's important to note, though, that if you're using these validation functions to validate your parameters, this is going to, if it is not an absolute path, if it is not a Boolean, or if it is not a string, it will cause catalog failure. Yes, sir?
Question. In the previous slide, there was an inheritance and a statement. Is that where the validation functions are, whatever it's inheriting from? It's a little hard to tell from the blue.
Yeah, I tried to change. We went through several color schemes, and a monitor is much different than a projector.
To be sure.
So yeah, this is actually inheriting the params PP. So back to that params PP pattern, the same defaults, that's what it's inheriting.
And is that where the validation is happening?
The validation is not happening there. It is actually happening right in between inherit and right above package, and I will show you that here in a moment.
Okay.
So again, note that if you are using these, it will cause catalog failure. You will not be able to apply it, it'll just outright fail, which is probably what you want in this case when you're validating. You want the user to know that, hey, this is not a Boolean, this is not a string. Use one. However, I think you need to remain a little bit flexible in the way that you validate. A lot of people aren't going to pass straight up true or false, or some external node classifiers, like automaton, pass strings instead of Booleans. So somebody even may do a human style Boolean, like T or F, yes or no. Somebody could put 1 or 0. But it is still a Boolean. They are still using it like a Boolean in the way that you intended to use. So don't slap them in the face and cause them frustration. Be flexible. Another good example inside of the standard lib module, they give you string to bool. So instead of doing the validate, which will give you this, T is not a Boolean, looks to be a string. So instead of slapping them in the face with that, you can be a little bit more relaxed. Assign that to a variable that's going to be internal to your module. This is not a parameter, but it is being sanitized by the string to bool function. So now it's changing that to T. It's going to change that into a valid Boolean that then you can use elsewhere inside of your module. You can actually see down here what string to bool converts. 1, T, Y, true, yes, then true. So that's pretty helpful. Again, that is in the public lab standard lib module. So you just want to convert the thing and move on. Let your user use the module. This is an example from one of my modular skeletons. A modular skeleton is something that you can use to quickly scaffold a new module. So you don't have to copy and paste everything that you're doing or clone. You could use CP, sed, a script, whatever, doesn't matter. But you should at least start with a skeleton that you know that you're validating, you have all of your parameters in there, and you're being documented. So this example is from my skeleton called standard food. And you can see how I'm validating, but I'm validating here in a relaxed way, and I'm sanitizing these Booleans. So next, if you're supporting different operating systems, you need to validate against those operating systems. You don't want these, you don't want your module that's intended for Red Hat to be running on Debian, or Oracle Linux for that matter, even though it's a Red Hat variant. So you need to let the module consumer know. So we see now we're in our params PP class, and this is what is setting all of those parameters. So we have our same defaults here. In our case statement, this is the most typical way to validate your operating system, is to go into your params PP class, create a case statement based off this fact. So this is the fact, OS family. And if you run factor OS family, you're going to get what operating system family that machine is a part of. So here we have Debian. So we're going to set all of our Debian same defaults. Here we have Red Hat. We're going to have all of our same Red Hat defaults. But we have a default fail. So that way, if it does not fall under the operating system that you're supporting, they're going to know. You can use, fail takes any sort of error message or message at all. So you can go ahead and put something meaningful in there so it just doesn't fail out with something. Now, my personal preference for doing this is a little bit different. This is totally a matter of style. I prefer to simply put a selector inside of params pp saying that if this is supported OS, Red Hat, Debian, and my default are false. I then actually go into my main foobar module and I put this logic in here. Just a simple if statement. If my supported OS is equal to true, then go ahead and do what you need to do. Apply the module, install the package, lay down the configuration file, start the service or not. Else, notify me. So this is a matter of being flexible or failing out hard. Most people will fail out hard and just let the module consumer know that, hey, this isn't supported. I prefer to notify. This is, again, preference. The reason being is I want all of my other modules to be applied. I don't want my catalog to stop. So I'm going to be notified on my Puppet Master and on the run that this is not a supported operating system. But all of the other modules do get passed.
Question. So if you notify and have dependencies, will those fail?
If you notify and have dependencies, yeah. So notice the only thing you're doing in the else is specifying a notice or a fail. All of your logic, so if you did have dependencies, are going to go into the first part of the if statement that equates to true. So this else is only for failing out or notifying the user.
So if you just made it notify, it won't stop all of the ones from applying?
No, it will not stop all of the other modules from applying. They will still apply, but you will get a message saying, hey, this module is not supported, in this case. So this operating system is not supported. But all of the other modules that are being defined in the node definition, those will absolutely continue to go, unless they also are not supported. So again, that is a matter of personal preference. You can fail and stop the entire catalog from being applied, or you can just simply notify. I prefer to notify. So public and private classes, standard lib in 4.4.0, I think, do not quote me on that either, introduced a function called private. So what are public and private classes in terms of a module? Why should you even care? So at their simplest, a public module or a public class is something you intend to be called directly. This is something you intend to alter. A private class is something you do not intend for people to call directly. It could be doing some heavy lifting internally to the module, and there's no parameters that can be overridden in it, but its settings are being set by those parameters. Private is used very easily. So say that server does a lot of my heavy lifting and installs a server instead of a client. Somebody calls that. This is site BP. I have my node definition here, and I'm going to include foobar server, but it's a private class. I'm going to be notified of this. So notice I can add a private message or a message to this however I want, again, so you can add something meaningful. This will allow you to force people through that API that you spent so much time on. It will make them go through all those parameters and use the module the way that you intend instead of piecemealing it. Until this function, I haven't really found a good way to prevent that, but I've only started recently using it, and so far I'm pleased. So we have all this flexibility, we have this public interface. Now it's time to standardize a little bit. So with standardization, you want to make sure that modules are documented. You want to make sure that you're using semantic versioning. And I'm not going to go through a whole lot about semantic versioning because this hard to read URL, semver.org, looks like I'm out of time. Semver.org is, will have all the information you need about that. Puppet Lab Style Guide Check out the style guide. This is all those the small things that I told you about, arrow alignment, double quoting when there's variables or not. This is going to show you how to do that, how to order your attributes. So please check this out, and it's your first step towards standardization. Next, check yourself. Make sure that you are actually using that style guide. Puppet Lint is a tool that it's a very simple tool, Puppet Lint, and then path to your init PP. This will tell you if you're out of style compliance.
Does it also, quick question, does it also check syntax like braces and dash brackets?
This does not, but the Puppet parser validate, that will.
Thank you.
Module documentation, document your modules. So notice I have this here. This is part of my skeleton. If you document your skeleton that you generate your modules from, you're not going to have to write this every time. Make sure you have this. This is what your users use Puppet Doc. They're going to use Puppet Doc on your module, and this will output a list of parameters that they're able to override. So they know these are the things that I can use to drive that module behavior. So you heard me say that my modules and my module skeletons are based off standard mod. I think it's a great community initiative. This is an initiative started by the guys at Lab 42. It's a community-driven effort to standardize parameter names. If you notice in that throughout my examples that I've been showing, those parameter names follow this proposed convention. A prefix, the resource type, followed by the resource attribute. So I have a config file path. So I have the file resource and its attribute path. Package resource, attribute name. Package resource, attribute name. File resource, attribute path, but I have my prefixes. So I encourage you to go look at standard mod. A standard mod compliant module adheres to these naming conventions. So if you download one of my modules or another standard mod module, your parameters are going to be the same. So you can interchange those very nicely. And notice how common sense they are and very easy to read. There's quite a bit more, but it's essentially endless. So module skeletons, if you go on GitHub, these are the 3 most popular skeletons. Again, mine is based off of the standard mod here, but these are 2 really, really good ones as well. They're all very opinionated, so you may not agree with some of that stuff, but that's what it's about. Contribute back and issue pull requests. Really quickly, if you use one of these, you can do Puppet module, generate an example module, and this will use that skeleton to give you a quick scaffold for your module, so you can go in and edit and change whatever you need. But all your parameters are going to be there already, all your documentation, tests, what have you. So what's changed in the foobar module? We have module documentation, standard naming convention, data separation, choices in how to manage the modular resources, decommissioning of single resources, decommissioning of the entire module, dry run support. So these are things that allow you to be flexible, allow you to be interchangeable, and allow you to be standardized. So thanks for listening. I can take any questions out of band. I don't think I'm going to have that time.
One quick question, since it was so dark to read your slides, are they going to be available somewhere?
Yeah, absolutely, yeah. I'll be providing them the Puppet Labs, and they will be putting them on their site, as well as my horrible public speaking presentation here today.
Good.
So.